Let's solve some problems. Let's say we are given f of x is equal to x square plus 2. Let's make it neater. At when x is greater than 1. 2x plus 1 when x is equal to 1. And 3 when x is less than 1. Now what we have to figure out is the continuity at x equal to 1. Okay, remember the conditions. For it to be continuous, the left hand limit, right hand limit should exist. Then f of 1 must exist. Let's look at LHL. So if we are talking of left hand limit, what happens? We are going to talk about x equal to x tends to 1 minus, that means less than 1. Less than 1 is 3. So our function would be f of x equal to 3. So limit as x approaches 1 of f of x is going to be equal to 3 itself. We don't have to do any further because it's a constant function. Change in value of x doesn't have any impact on the result. Okay, let's look at RHL. Now f of x is equal to, now what happens? It is coming from the right of 1. Right of 1 means it is greater than 1. So here the function becomes f of x equal to x square plus 2. Now limit as x approaches 1 from here it is from the left hand side. From the right hand side of f of x is equal to limit as x approaches 1 from the right hand side of x square plus 2. This can be written as limit as h approaches 0 of 1 plus h square plus 2. Limit as h approaches 0 of 1 plus 2h plus h square plus 2, which is equal to limit as h approaches 0 of 3 plus 2h plus h square. Now let's take the limit. So basically we make h equal to 0. Then what happens? We are left with 3. So LHL and RHL exist. Yes. And LHL is equal to RHL. Now we have to figure out the other condition, that is f of 1 should also exist. Now when it is equal to 1, what is this is the function 2x plus 1. So f of x is equal to 2x plus 1. So that means f of 1 is equal to 2 times 1 plus 1, which is 3. So limit as x approaches 1 from the left hand side of f of x is equal to the limit as x approaches 1 from the right hand side is equal to f of 1. So therefore the function is continuous at x equal to 1. Now let's look at the second problem. F of x is equal to 1 by 1 plus e to the power of minus 1 by x. Here x is not equal to 0 and f of 0 is equal to 0. This is the statement. Now what we have to figure out is it continuous at x equal to 0? Again LHL. So limit as x approaches 0 from the left hand side of f of x is equal to limit as h approaches 0 of f of 0 minus h. which is equal to limit as h approaches 0 of 1 by 1 plus e to the power of minus 1 by 0 minus h. Limit as h approaches 0 of 1 by 1 plus e to the power of minus 1 by minus h. So this becomes 1 by h plus. Now we can manipulate this in different ways. So h, what we can do is we can divide both numerator and denominator by e to the power of h. So 1 by e to the power of 1 by h by 1 plus e to the power of 1 by h, e to the power of 1 by h. H approaches 0 of e to the power of minus 1 by h by, here what happens, e to the power of minus 1 by h plus 1. And now we actually take the limit. So when we take the limit, what happens? As h becomes smaller and smaller and smaller, the denominator becomes smaller and smaller and smaller, 1 by h becomes greater and greater and greater, right? So look at it like this. As h goes to 0, 1 by h goes to infinity, e to the power of 1 by h goes to infinity, but 1 by e to the power of 1 by h goes to 0. Yes. So this goes to 0 by 0 plus 1, which is equal to 0. Limits at infinity and limits at infinity and infinite limits. You have to be very, very comfortable with that. Okay. So RHL, limit as x approaches 0 from the right hand side of f of x is equal to limit as h approaches 0 of f of 0 plus h. Now limit as h approaches 0 of 1 by 1 plus e to the power of minus 1 by h, and we can directly take the limit. So 1 by 1 plus e to the power of minus 1 by h is 0 when we take the limit, which is equal to 1. Now you might be wondering, I took it directly here, and here I went through all this natak, I went through all this drama. This is just to show you that there are different ways of arriving at the same result. Some are longer, some are shorter. Now we know left hand limit and right hand limit both exist, but LHL is not equal to RHL. Therefore f of x has a discontinuity of the first kind. Let's look at the next problem. Let's try to figure out the discontinuity or continuity of f of x equal to sine 1 by x at x equal to 0. So LHL, limit as x approaches 0 from the left hand side of f of x is equal to limit as h approaches 0 f of 0 minus h. Now let's actually write it in terms of the sine itself, as h approaches 0 of sine minus 1 by h, which is equal to limit as h approaches 0 of sine minus 1 by h is minus sine 1 by h, which is equal to, and this you can't really put a definite value to it. It's going to be a value from minus 1 to 1. So a finite value but indefinite. That means we can't specify a single value. So therefore no LHL or RHL exists. So we can say f of x has a discontinuity of the second kind at x equal to 0. Okay, let's look at the next problem. F of x is equal to 3x square plus 4x minus 5, and we have to figure it out at x equal to 1, the continuity. So LHL, let's figure out the LHL. So limit as x approaches 1 from the left hand side of f of x is equal to the limit as x approaches 1 from the of 3x square plus 4x minus 5, or we can say limit as h approaches 0 of f of 1 minus h, limit of h approaching 0 of 3 times 1 minus h square plus 4 times 1 minus h minus 5. So limit as x, not x, h approaches 0 of 3 times 1 minus 2h plus h square plus 4 minus 4h minus 5. Okay, so limit as h approaches 0 of, this whole thing is in a bracket, 3 minus 6h plus 3h square plus 4 minus 4h minus 5, which is equal to limit as h approaches 0 of 3 plus 4, 7 minus 5, 2 minus 10h plus 3h square. Now we take the limit. So when h goes to 0, these two terms disappear and we are left with 2. Okay, now let's look at right hand limit. Limit as x approaches 1 from the right hand side of f of x is equal to limit as x approaches 1 from the positive side of 3x square plus 4x minus 5, which is equal to, we can write it as limit as h approaches 0 of f of 1 plus h. So limit as h approaches 0 of 3 1 plus h square plus 4 times 1 plus h minus 5, which is equal to limit as h approaches 0 of 3 times 1 plus 2h plus h square plus 4 plus 4h minus 5, which is equal to limit as h approaches 0 of 3, here the bracket closes, 3 plus 6h plus 3h square plus, let's say, minus 1 plus 4h. Limit as h approaches 0 of 3 minus 1 is 2 plus 10h plus 3h square. And now let's take the limit. So now when we take the limit, what happens? These two terms disappear and we are left with 2. So LHL is equal to RHL is equal to 2. That means they both exist and they are equal to each other. Now we have to figure out f of 1. So f of 1 is 3 times 1 square plus 4 times 1 minus 5. 3 plus 4 minus 5. 3, 4, 7 minus 5 is 2. So the limit exists and f of a and the limits, they match. So we can say the function is continuous at x equal to 1. Even otherwise also, no? as we saw before, if it is a polynomial function, it is going to be continuous for all real values. So we don't have to do all this. We can just say, since it is a polynomial function, it is continuous. Now let's look at the next problem. Let's say we have a function f of x is equal to minus x square when x is less than or equal to 0. 5x minus 4 when x is between 0 and 1. 4x square minus 3x when x is between 1 and 2, and 3x plus 4 when x is greater than or equal to 2. So be careful about that, less than, greater than, and less than or equal to, greater than or equal to. That can become tricky. Now what we have to figure out is the continuity at x equal to 0, 1 and 2. So let's look at x equal to 0. LHL limit as x approaches 0 from the left hand side of f of x is equal to limit as h approaches 0 of f of 0 minus h, which is equal to limit as h approaches 0 of minus 0 minus h square, which is equal to limit as h approaches 0 of minus h square, which is limit as h approaches 0. Actually we don't have to do all these things. Directly we can say it goes to 0. Now what about RHL? Again, limit as x approaches 0 from the positive side or the right hand side of f of x. Okay, so here remember, here we took minus x square. Why? Because we are talking of left hand limit at x equal to 0. That means less than 0. So less than 0 is this. Okay, now what happens? We are talking of right hand limit at 0, which means what? It is going to be greater than 0, right? Since it is going to be greater than 0, we have to look at 5x minus 4. So as x approaches 0 from the positive side of 5x minus 4, this can be written as limit as h approaches 0 of f of 0 plus h is equal to limit as h approaches 0 of 5 times 0 plus h minus 4, which is equal to limit as h approaches 0 of 5h minus 4, which is equal to minus 4. So here LHL not equal to RHL. So therefore discontinuity of the first kind, yes, that is at x equal to 0. Now let's look at x equal to 1. Now f of x is equal to, when x is equal to 1, it is f of x minus 4. Now let's look at LHL, that is limit as x approaches 1 from the left hand side of f of x is equal to limit as x approaches 1 from the left hand side of 5x minus 4, which is equal to limit as h approaches 0 of 5 times 1 minus h minus 4, which is equal to limit as h approaches 0 of 5 minus 5h minus 4, which is equal to limit as h approaches 0 of 1 minus 5h. And now when we take the limit, it is equal to 1. Now let's look at RHL. limit as x approaches 1 from the right hand of f of x is equal to, now right of 1 means what? It is greater than 1. Greater than 1 means yes. So 4x square minus 3x. Limit as x approaches 1 from the positive side or the right hand side of 4x square minus 3x. And this can be written as limit as h approaches 0 of 4 times 1 plus h square minus 3 times 1 plus h, which is equal to limit as h approaches 0 of 4 times 1 plus 2h plus h square minus 3 which is equal to limit as h approaches 0 of 4 plus 8h plus 4h square minus 3h. Limit as h approaches 0 of 4 minus 3 is 1 plus 5h plus 4h square. And now when we take the limit, it is equal to 1. Now LHL is equal to RHL and they both exist. So limit now let's figure out f of 1. F of 1 would be equal to 5 times 1 minus 4. So 5 minus 4, which is 1. So limit as x approaches 1 of f of x equal to f of a. So therefore continuous at x equal to 1. Now the remaining one is at x equal to 2. That I will leave it to you for practice. Enough for today. Bye for now.